surgical robotics department. But sadly, I'd say people ask me now, do I buy it? I say it's very dated, so the API has changed a lot. So they still sell it on Amazon. I keep telling you, that team, they don't take it down. So I work for SerialDB, but I'm also an honorary researcher in the surgical robotics department at King's. And if people don't really know, King's kind of just got the funding for the London Institute of Healthcare Engineering. So a lot of academics from Oxford, Cambridge, UCL, so just all came to King's. And one of my old supervisors just said, I'm going to King's. I said, I'm going there. And he said, okay, that's where it's all happening. And I'm introducing Rust into surgical robotics there. So we look at async interfaces with GPUs, and then we can obviously stream high volume data into that sort of thing as well. So if anyone's interested in that sort of stuff, GPU inference, definitely talk to me. And this is SerialDB is my day job. So it's just a database written in Rust because it's written in Rust. It runs in WAS on the browser, and Reddit. It also runs in the cloud. So yeah, it's good fun. So the journey kind of started because I got some funding from the German government with a friend. Well, my friend got the funding. I kind of tagged along, and it was medical simulation software for the German government. And we got a lot of freedom. It was just us, right? So we said, let's use this as an experiment. Let's build our own Kubernetes cluster in Rust. And we rewrote it 3 times. We did loads of things wrong with it. That's why there's 3 editions of the book, because we kept doing new things, and then we said, this is great. And then later on we said, oh, this is terrible. And then we keep writing the new book, and then people say, should I buy the old one? You're like, no, seriously, wait till the next one. So the third one is definitely our best one. So hold off to the third one. But this is our structure, and there was only literally 2 of us, so we had to constantly think of new ways to make things like testing, where you make it very versatile, very easy to deploy, because there's only 2 of us, so we can't just chuck more engineers at it. So we came up with this modular approach to deployment. And what this is kind of we call it nanoservices. And what that essentially is people say, oh, do you just deploy loads of servers? The deployment's not really that important. It's more about the size. So nano, micro, you just have multiple nanoservices and 1 microservice. But it doesn't mean that we just have loads of pods. In fact, it ends up being the opposite. We only have sometimes just 1 binary, because they all compile into 1 binary, including the JavaScript. We managed to compile the JavaScript front end into the binary as well, and the SQL and everything, so it's just doing 1 binary. But we can burst it out. So the way we do that is that we have 3 workspaces. So these are 2 nanoservices, and we have a data access layer, that's its own workspace. We have a core that doesn't have any dependencies on networking or data access. And then we have a networking layer. And networking layer could be any sort of network. It could be TCP, it could be ATIX, Axon, it doesn't matter. And what you essentially have is the data access is a dependency for core. And then the networking kind of builds on that. And then we also have this crate that's called Glue. It's not very original. It sounds a bit weird sometimes, but I couldn't think of any other way. And essentially it's stuff where you want to propagate stuff like, let's say, error. You want to propagate a certain error type all the way through all your workspaces. So every single workspace kind of uses that as a dependency as well. And then you can start to connect to a database and you get traffic coming in. But the flexibility of this, it's working, is that let's say you want to compile them both into there. Your core on the right could just point to the core on the left and compile it in and call it via, functions directly. So you just basically smash them together. And with the compilation features, that's actually very powerful, right? So you can say, okay, I wanted to compile and actually be the networking layer, or I want to compile just the core. And obviously you just have a slightly different dependency and a slightly different sort of code in there. Or you can do, and this is where we compile everything, including the JavaScript, you can just compile the networking into just another Rust server, and just call it egress or whatever you want to call it. So in your networking you have a main, so you can run it, but you also have a lib, you export all your factory, your API inputs there. So they kind of all plug in together as well. So we can start our journey with the data access layer. So let's say that we're going to do a to-do item. That's always the nice one that I pick. And the first thing we notice is the nanoservice error. You see that's from Glue, and we implement the 2 HTTP response. So that means that whenever this error bubbles up, it just automatically converts into a HTTP response and goes back. That means that we can exploit error handling throughout our whole system, because this is going to be in the glue. And then we have in our data access, we have this trait, right? And we call it save one. And you can see here that it's just like a signature, right? We're creating a to-do item, and we're saving it to our data. So if we look, we return a future, and it has that save response, which is either the item that we stored or the Nanoservice error. And we also have some descriptors. So we implement it for an SQLX Postgres descriptor. We also do it for a JSON file if you want that. But remember, we can do anything, right? Because it's just a signature. So we can actually have a descriptor that's HTTP request to another server. We don't care. We can just slot these in and out depending on the feature. So with that, that's our data access layer done. And we can move over to the core. And you can see here, we use the glue again. Oh. And we've got the crate, right? And we have that save one trait. So that means that we can slot anything into the create here. So we still got that signature, but we can do different descriptors now. And the core is basically our logic, right? We don't have any dependencies on I/O or networking or anything like that. We just focus on the logic. So this save one, I don't know why it happens like that. I've been playing, I'm very new to these sorts of animations. And then you could put something fancy in there, right? Obviously in this example, it's a bit redundant, we're just wrapping it around, but hopefully you do more things in your core. You may check the limits based on the idea of the user using it or something like that. So we can actually test this now. This gives us a very powerful base to test, right? So in the save one, we can see that we just create a struct, an empty struct, and we implement the save one on this. Oh. And you can see that we just make some stuff up, right? Because we're just testing it. So if you don't put in coding, it's going to panic, and it's going to give you an invalid title, right? And that's kind of what we want, you know. We're all coders. We don't really want to do anything else. You can just say to your wife, but it's going to crash if I don't do this, right? And then we also have some things here with the user ID, invalid user ID, and if we put everything right, then we get OK. And this is just our test. And then we can just test it, right? Because we can put our return mock into our test. So this gives us some really quick feedback on, we don't care about the I/O, we just care about the logic. We just care about the logic of our app in our core. So now we move on to our networking layer. And you can see that there's like a lot more now. So we're just importing the DAO, data access layer. We import our core, and we've got our core functions. We import our glue, and then we import the Atix web stuff that we need, you know, so we can actually say, okay, let's do some networking now. And I've also got like an auth kernel, because this is actually from some working code. So this was talking to an auth server, and we did a get user session. So we embedded like Rust into Redis as well. So you can embed Rust into Redis, so you can run some logic in there and directly access the key value stream. So that means that you can like do some logic. Instead of doing multiple requests back and forward in Redis, you can just run your code in Redis. You know, you have one request. So now our create is looking quite cool, right? We're starting to just chain them up. As you see, that now we've got these Lego blocks. We can start getting really surgical with them. So we've got a token, we've got a header token, and this is obviously off screen, but we implemented the from request trait. So if you put that in, it'll automatically get it from the header. So you slot that as a parameter into any view, and you'll get your token authentication. It will return an unauthorized if the token's not there or it doesn't, you know, it's not compliant. And then, because we implemented the serialized and deserialized traits, our to-do item can just automatically get extracted from the body and passed in here from the HTTP request, because we wrap it in a JSON that's supplied by Atix. But all other frameworks also supply this sort of stuff. And then you can see that we start to like stitch them together. So there's also another trait that's like get all. So in our to-do items, we want to save one, and then we want to get all the to-do items just to return, to say like what's the state of the to-do items. And you can see with the X, we get our user session, and then with our handle here, we've got save one and get one. And again, these could be separate, right? Whatever you want to implement there, one of them could be a HTTP request. As long as it's got that signature, it doesn't matter. So, we've also got our nanoservice error. And you can see here the question marks. So this is just all slotted together, and if it errors in any of these, it just returns a HTTP response with an error code that you defined in your nanoservice error. So that's starting to look really nice, right? I get really annoyed when people say Rust isn't for web programming, it'll take you ages to build stuff in Rust, and I'm just like, learn traits, come on guys. Like, this is, as soon as you learn traits, everything just slots in, it becomes ridiculously flexible. And you can still unit test. So now we want to hook, our view onto our server. So that service config, there, we pass in our server, and it basically just attaches the API endpoints to it. So you can see here that we just hook up the Redis descriptor and the Postgres descriptor, and there we are. So now you can hit that, and it's going to hit that. It's going to hit those databases, and it's going to do everything for you. You can also test this now. So the service response and the request there is provided by Attic, but there's other ones as well from different frameworks. So that means that you can also unit test your HTTP endpoint as well to see how it goes. And we've got a mockDB handle and a mockDB session, which I'm not going to show you because it's just bloating it, but you can imagine now you just implement the trait that you want with the response and that sort of stuff. And this is the code that kind of looks like its own. So you do a test request, you do the actual, you put the token in, that sort of stuff, then you can actually send it, and then you can like extract the status. Exactly, right? So you can unit test. You can unit test your core, you can unit test the functions, and you can unit test how it actually work as a HTTP request before you've even run anything, which is crazy powerful. When you combine that with type checking and all this, like, people think I'm lying, but I used to write Python servers, and I actually developed out at a quicker rate when I write Rust servers, because I just don't get the errors, I get the flexibility, I get the modularity, I can just chuck it all in. So, well, now we're going to go on to our ingress, we're nearly there. So, now this is a different workspace, and it's going to compile both of those together, because you say, okay, I like that, but I just want one binary. I don't want to deploy it yet. I'm not ready. Microservices are a headache, right? Like, you've all gone to a startup and they've got like 2 developers, and they've got like 5 users, and then they've got like microservices. And you spend most of the time developing microservices. Microservices are useful when it grows and you don't want the headache of like trying to break out a monolith when you have these small teams. So this is what we came up with. Like, we still just want to deploy that one binary. It's just me and my friend. And the German government's using it, we just want one binary. We don't really want to have a whole orchestration. So, this is what it is. So we have our migrations, SQLX kind of embeds your SQL migrations folders into the binary anyway, and it will run them. Then, we've got our configure. So we've got those views factories that I showed you, where we mounted them on with the descriptors. So we've got one from the auth server, we've got one from our to-do views, and we just put them in. And then we say, like, we've got a default service. And we say, okay, if you didn't hit a backend API endpoint, you're going to get the catch rule. Because we also want to serve our front end, right? Because we want it all in one binary. So, this is our catch rule. Did I do this? Yes. So you can see that if the path actually has API, we just came up with a naming convention. All backends have API in the path. So if it has that and it's hit the catch all, that means it tried to get a backend request and it didn't get it, so we just return a not found. But then our React app is stored in front-end public. That's where we do our builds. That's where our minified JS is. That's where our CSS is, and all this. So we got this function that says serve front-end asset. And then I'd love to tell you exactly how this works, but I don't know. It works. But there's this thing called bind guess. It's a crate, and it can look at your path, you can look at the file, it can guess what type of file it is, right? So if you're just trying to hit it, it'll say, oh, it's a CSS file, oh, it's a JS file. I'm going to serve it, I'm going to put it in the headers. So that saved us a lot of heading. And then we serve that, and our serve front end, we essentially just, if we can't find the file, we can't process it, we say it's a bad request, But then, if not, we actually just do front-end assets, we get the file, and then we serve it. We serve it to the front end. And that front-end asset is this crate called Rust embed. So you just point Rust embed with this macro, we call it front-end assets, and you point it to the directory, and you just embed all of them into that. And then you just call it like a file, but it's actually embedded into the binary. So there you are. You have your whole, your whole microservices all into one binary. But it's also well structured that when you do grow and you do get more and more devs, you can say, don't worry, I've got this, right? I can just break this out. It's going to be fine. Like everything's structured, everything's reusable. And that is it. So I've got some open source projects, because some of you say that you want to get involved in Rust, so I've got some really easy ones for people to get like a flavor. So I'm not trying to revolutionize, web programming. Instead, I'm using kind of like building these small things that kind of just make it easier. So you can kind of orchestrate more projects. It's just easier to test them. It's easier to build them. It's easier to package them. So this is the first one, is a doc pack, and it basically just says you put your files, so your Rust files or whatever files you want, into a Docker image, and you push it up to Docker Hub. So it's private, right? Because you can authenticate. You can have your own private images, and then what you do is you say docpack pull. You point to the image and you point to a directory. It will download the image, and then it will go through all the hashing and all the manifests and unpack all the files. So we use that ourselves for private crates, because you already have Docker on all your CI. You don't want to pay for like something else. I tried using Shipyard, and it was just another headache. You have to authenticate something else, and you have to use. So I'm just like, okay, I'm already using Docker. So what I'm going to do is just download it, point it there, and in my cargo, I just point to where I'm going to download it. It works. So there's always more features. So if anyone wants to get involved in that, it's a very basic tool. It just does a bit of unpacking and zipping. It does some calls to Docker. That's about it. But we can put some more nice features. It's a very easy one to get involved in. I've also got Nanoservice utils. So those Nanoservice errors that you saw, they're kind of on this crate. So this crate now has over nearly 8,000 downloads. It's quite cool. We've got some companies who are using it in production because it just propagates those errors all the way through. And it just obviously supports error response for Attic, Rocket, Axon, and Hyper. We can also add more, we can add some more features. Again, it's a very easy crate. And we've got some stuff with JWT, some configs, some runtime states. And then finally, I posted about this on LinkedIn. I've got a bit of addiction to the pure WASM, the assembly. I wanted to learn what it was all about. So I've just built a tool. It's in Python. Admittedly, it's not Rust, but it kind of just profiles the memory of the WASM module that you're building, so you can actually see exactly how your WebAssembly alters the state. So what this is a memory allocation code, and then you can see like this is like allocated. Oh, actually, we've got it. Yeah, there we are. 0 is unallocated, 1 is allocated, and then this pointer goes to like the next one that's free. There's obviously -1. So you can see how it like goes through when you're calling the free function and then malloc function, that sort of stuff. So if anyone's interested in pure WASM as well, we're trying to get it off the ground. And that, I think, is it. So please keep in touch. There we are. Any questions? Yes.
So, given that it seems like you use a lot of traits, how much does that impact compilation time?
What was the question there?
Yes, yeah, sorry. So I use a lot of traits. How does that, affect compilation time? To be honest, I haven't really checked it, and now you said it, I will go and check it. To me, it hasn't annoyed me that much. I think we kind of all get Stockholm syndrome with compilation, so when it compiles in Rust, we're just like, yeah, it's going to take a while. But I will check it, actually, it's a good point. Yeah, thank you. Yeah?
Hello. Right. If you have been asked to convince a huge organization which is already using JVM-based languages like Java, Scala, Kotlin, and their framework like Spring Boot, because they're spread across locations with different time zones developers, there are huge applications. If you have been asked to convince them to move to Rust for web development, maybe 1 or 2 points, how would you approach this? those days? Like, what's your point to convince to move to Rust? Because of the steep learning curve on different time zones, people are already so used to, like existing frameworks.
Yeah, I've tried to convince quite a few people. I've succeeded a couple of times. I think it's just, you've always just got to try and say that it's easier than you think it is, right? And that's why I try and make it as simple as possible with these traits, with these layers, with this, and how flexible. Because I think there's a lot of misinformation online where people say, it's very unforgiving, but you saw those traits, it's not, it's actually very flexible, you can't retest it, yes you can. The borrow check is a bit of a headache, but then I think if you show these high-level abstractions, you'll actually save time, with a lot of this. I actually found, as I said, I developed Rust servers at a quicker pace, and I think that's what you've got to really sell, because I think everyone knows that Rust is super fast, everyone knows it's super safe, everyone knows that you can embed it into Postgres, Redis, Nginx, all this sort of stuff. But everyone says, it's a steep learning curve, it takes a long time to develop. There's YouTubers online which are really frustrating that say, don't use Rust because it just takes way too long to develop stuff. Yeah, so you just got to basically say, it's quick, it's not that hard, it's really flexible. You just got to keep doing that sort of stuff.
I think it will encourage everyone if there is a very easy to use framework comes like in Rust, like for web development, very, very easy to use, something like Spring, for example.
So we're going to keep trying to produce material and tools to make it easier and easier for people to get started. Somebody put their hand up. Yeah? You first, yeah?
Thanks. So I've been writing Rust for a few years now, but I've only been using WebAssembly for the last maybe 6 months. But one of my questions was, what sort of tips do you have to optimize the developer experience using WebAssembly? Because we've got a lack of debugging tools. I'm using some crafty C++ debugger that's built into Chrome. Obviously, there's instead of having live preview, you've got compilation times. Every single time you want to run your web app again. What are the top tips and the best things in your experience to optimize that experience?
It's quite underwhelming. My experience is that a lot of the tools are still quite bad for us, right? So even standard debuggers half the time, even my LSP, a lot of the time, VS Code just sometimes stops working, shut it down and stuff like this. So if my LSP is not working that well, I haven't really reached for debugging tools. I've kind of just gone the opposite way. Luckily with Rust, you're not really going to get much legacy code, right? So I would advocate you just keep your functions super small, keep those traits aggressive, and unit test. That's pretty much the only way that I've managed to keep on top of it.
We're writing a rendering engine for WebAssembly at the moment, so keeping it small is going to be quite difficult, but we're going to try.
I'd love to talk to you about that, because I don't know anything about rendering. So. And someone next to you.
Is this deployed in a distributed fashion?
So we have deployed it in distributed fashions, and we also deploy it in single binaries, because you can just select how you compile it. There's something that I didn't put in there actually, and that is that we use distroless builds. So distroless builds are they've got nothing in them really. If you SSH into a Docker image or a container that's running, and it's distroless build, there's not even a terminal. So it's actually quite safe as well, so hackers can't do anything. So what I'm doing at the moment is I'm compiling all my servers and the ingress, putting them in the distroless build, and just copying over the SSL, the libc, the bare minimum. And at most, with multiple servers, all the front end JavaScript compiled into the binary, everything, the whole system is like 100 megabyte image. So then we have these range of binaries, and then whatever command you pass into it. So you pass in the ingress one, it will just do that. If it's the same image, you pass in the auth command, it will run the auth server because all your binaries are just in one. So you can burst them out into microservices if you want, basically.
So one more question. The networking part you showed, does that do service discovery and service mesh, sort of stuff?
Service discovery? No, I kind of just use Kubernetes and stuff for managing, orchestrating multiple things, yeah.
Got it.
Maybe one day if I learn how that works. We've got quite a few, but this lady's going to pick them.
Yeah, thanks for your talk, that's really interesting. My question was with the layers that you have. So you've got the data access layer for the networking. Where would you go about maybe putting something like an open API endpoint that sort of generates that endpoint for client generation, or also let's start with that one.
So from what I understand is that you want to generate some templates or something with all the boilerplate done. Is that?
Right, like it's like an export for two API endpoints, so that you can generate client code to talk to your service.
Oh wow, yeah, that'd be cool. I mean, I'd really like to do that. Yeah, it's limited time. I'm excited that there's such a turnout, to be honest, because hopefully some other people get involved. Because it's literally just me and my friend who've been building these things. Yeah, that'd be awesome. Yeah.
Thanks. That's all.
There's a guy, right? You had your hand up?
You mentioned you worked with Surreal. Oh, sorry.
Yeah.
Yes. You mentioned you work for Serial DB, so I was just wondering if any of your work is kind of being integrated into Serial DB.
Yeah, so some of it, yeah. The ML stuff's got integrated, building the Python client with the bindings. Nanoservices utils is now in Serial DB in terms of like the cloud infrastructure and that sort of stuff as well. So they've been quite supportive in that sense, but I guess they're quite radical in their approach anyway, right? If you're going to say you're going to rewrite a database and there's already stuff in Postgres and that, they're already quite heuristic, and so they're good at that as well. So.